Hello YouTube, welcome back. Today we're going to discuss the scientific method. So where does the scientific method start? What does it begin with? Well, in its simplest form, it starts with an observable phenomena, something in the natural world that we do not understand, or that we can see happens but don't have an explanation for. And then you have an idea. What you do once you've got your idea is you formulate a hypothesis. You come up with an attempt at an explanation for the phenomena that you are observing. What you do then is you design, construct and analyse experiments. You conduct these experiments to try and gather data, and data can take many forms. For example, the London tube map. This is data. This is data. Each one of these photographs is a datum, that is to say, a single piece of data. We publish it in a peer-reviewed journal. Something like this. We've got the Journal of the Geological Society, Nature, New Scientist and National Geographic. Now, two of those, admittedly, are more in the popular vein, namely these two. But each and every single one of these has a peer review process. So, how does peer review work? Well, it's actually fairly simple. We take our hypothesis, we write a paper on it. This happens to be a paper on the possibility of soft tissues and proteins in Tyrannosaurus leg bones, but that's not the point. We take our hypothesis, we send it to the publisher, and that publisher takes it and says, okay, what we're going to do is we're going to give this to some other scientists. Go on, take it. You then, as a scientist, read it, look at the data, and you write back and you say, this is a very bad paper. It doesn't cite its references, it doesn't do this, it doesn't do that. Or you say, this is a very good paper. It does cite its references. It does have solid methodology. And the journal will take that and go back to the original scientists who brought the paper forward, so in this case, you and I. And they say, we want you to do this, we want you to look more carefully at that, we want you to cite your references better. And after going around once or twice, and to anywhere between 3 to maybe 20 scientists later, 20 odd reviewers, the journal finally gets to a stage where it either says, we're not going to publish this paper because you can't make it work, or they'll say, we will publish it. And then, sure enough, a few weeks to months later, out comes a scientific journal. This one is Nature, fairly out of date one actually. And in that journal is your paper. And then it's out of the public domain, and the entire scientific community can look at it, and they can test it, and take issue with it if they wish. And if they do take issue with it, then they will either prove your hypothesis wrong, or they will falsify your hypothesis, or they will be unable. And if they're unable, that makes your hypothesis stronger, and ever so slightly closer to becoming a theory. So in just under 5 minutes, I've explained the 7 steps to the scientific method. From observing a phenomena, through having your ideas, formulating a hypothesis, conducting your experimentation, all the way through to writing up your conclusions, passing through the journal peer review process, and finally, and perhaps my favourite part, watching other people test, falsify or corroborate your hypothesis, getting you that little bit closer to having what might be called a theory. So in conclusion, the scientific method is a very simple but extraordinarily effective tool for getting knowledge and expanding the immense amount of knowledge that the human race has compiled over its history. I hope that this video has, at the very least, helped some of you to understand the intricacies of the scientific method, and I hope you've enjoyed it. Thank you very much, and have a nice day wherever you are.